When you have a certain set of laws that govern physical phenomena and you can investigate nature but on a piece of paper through analytic derivations or equations, for example, then you might uncover some phenomena that hasn't been observed yet, and really exciting would be to verify that through experiment.
The students are building an interesting experiment to build out something called a metamaterial. It's an advanced topic in electromagnetics. They're materials that can have non-physical or quasi-physical properties. As part of the lab that we're building out, we got this advanced prototyping equipment, and it can be used for all sorts of things. This is one of those things.
What we're trying to do is uncover phenomena that's not found in ordinary matter in terms of light-matter interaction, which is governed by Maxwell's equations. There are solutions to Maxwell's equations that permit the phenomena of negative refraction. We haven't found that in any ordinary matter. So what we do is we engineer media such that it exhibits this particular property of negative refraction. In the lab, what we've done with the experiment is we've developed an apparatus and had the students fabricate a sample that does have this property and verified it through experiment. We can control at will all the properties of electromagnetic waves using these media that interface with the waves.
5G changed the way that radio waves are propagated. We went much more to what are called active phased arrays. So my antenna aperture can steer a beam directly at a target. That works pretty well if there's nothing in the way. One of the things that people are looking at right now is something called reflective intelligent surfaces. We use things like metamaterials or antenna arrays or apertures where we would aim a beam at those things and get it to steer the beam around an object.
Electromagnetics is a field that takes a long time to get into and to really understand it. There's a lot of mathematics, right? So you get lost in solving problems and learning the theory, but to see the theory come to life when you actually have built something and you can hold it in your hand and you can show it to your mom at the dinner table is really important. It makes the subject come to life. The equations do predict exactly what you would observe in the physical world.